Hi there, we're going to talk about the term structure of interest rates today. Last part of the module. So here we go. What do we mean? We draw a little graph of T and then interest rates with I. Often in the course we've assumed that the interest rate is constant for whatever term we're talking about. So the length of an investment or length of a project, something like that. But in reality, these things jump around. So for instance, they might go up a bit like that. Sometimes they go up rapidly and then flatten off. Sometimes they fall. So what this is telling us is really the cost of borrowing varies by term. Now at the end of this talk, we'll discuss, or I'll mention some theories behind that. But the key thing for us at the moment is that the interest rates we use might not just be constant. We did have a brief introduction into this when we've looked at some deltas which vary by t. So the force of interest is a function of t. Remember where we have them things such as we have a function minus t over 0. T multiplied by 0.002 or something like that. Them sort of things, right? So we're not going to talk about force of interest here, so I'm just going to put a line through that. Okay. So the two main aspects of this module, or this chapter of the course, is spot rates and forward rates. So spot rates, here we go. So what are these? Well, they represent the interest rate applicable to discount a cash flow from t back to 0. So if you have I4 as a spot rate, that's the 4-year annual spot rate, as I say. So, and then if we work that through to come up with a present value of a cash flow at time 4, then we have that cash flow, and then it's 1 plus I to the 4 to the minus 4. This is the V function, as what we've seen a lot through time. So then say we have a 3-year one. So I'm just going to put 3 ... So that is the present value of a cash flow at 3 way through. Now, so you can see these things aren't necessarily linked together. You can have one which is much higher than the other. Now, if you continue your study into financial mathematics later on, you'll see that the whole way you construct spot rate curves and then forward rate curves is they are linked. We'll talk a little bit about that later. Otherwise, they lead to situations known as arbitrage situations, but you don't need to know about that for this course. So why do we use these? So an example, a use example, I'll call it. So we've got a gilt. So say we've got a 3-year gilt, annual coupon, and a redemption amount in 3 years R. So we can value that using spot rates, which are from the market. So each cash flow is discounted back by its appropriate spot rate. So if we put a formula for the price or the present value, just put that in brackets just so you know they're equivalent. You can have the coupon, year 1, assume. So these coupons are at 1, 2, and 3, not at time 0. So we can have 1 plus I1 to the minus 1 plus C2, 1 plus I2 to the minus 2 plus C3. Remember, it was a 3-year bond, so we're rapidly come to the end of this, plus 1 plus I3 to the minus 3. Okay. So you can see we've used the various spot rates to value this bond. Right, let me clear this. So don't save. Right, okay, now let's go on to forward rates. So forward rates can be viewed as the glue between spot rates. They don't have to start at time 0 and run all the way to the term of a cash flow. They can just be, for instance, a single year interest rate, say at year 2, year 3. For me, I've always used, in industry, I've always used forward rates more than spot rates. I've always kept an eye on the forward rate curves more. Because I find spot rates often you have to think back to the various duration, i.e. how long the spot rates are in force for. So for me, I'm a big fan of forward rates. But when I was around your age, I couldn't care less. It was just learn the formulas, really. Right, okay. So we've got a formula which we're given for these. So we say 1 plus the forward rate at time s. I better draw a timeline in a minute. I better draw that over here, in fact. So here's time 0. Here's time s, and then t. So that time interval is t minus s. So the forward rate at time s, so forward rate at time s for the period of time t minus s. Oh, see if I can replace that. Yep, that's handy. There is equal to the spot rate, which I'm just going to call I, for the whole period t to the t over 1 plus I to the s to the s. So if you think this is compounding that interest rate for t years, this one's compounding the s year one for s years. So you imagine 1 is going to there, 1 is going all the way there. It doesn't take a massive leap in faith to see that the forward rates is the link between the two here. So play with that, you'll get used to them. So this is a key formula. So this is key you need to understand and be able to manipulate all sorts of situations. Most questions are focused on these sort of relationships and kind of get clever with, the whole where it starts, how long, so that in this case the t minus s, and then making sure that you compound that for that correct period as well. Once you master it, it becomes like a little sub form of algebra really, and everything looks, all the questions will look pretty similar and pretty obvious. But it does take a bit of practice. I will put some practice questions up, so you should be able to get there in time for the 6591. Sounds like a train, but the 6591 exam. Now, in the course, I then go on to kind of continuous versions of spot rates and forward rates. So that was my lame effort to put some theory in. Difficult to examine. Okay, so focus on that. So difficult to examine. It is just theory, so you don't expect to see too much of that in the exam. But you might do. You never know. The key thing with this is the equivalent to when we done our interest rate theory. We sort of had, we had annual interest rates, and then we had interest rates which are taken half yearly, and then we had interest rates which are taken 12. These are all effective rates, if you remember. And of course then we had things like the nominal rates. And if you remember, the key to where we suddenly move from annual, then we start to move down to monthly, etc. Ultimately, we said, right, what about things which compound continuously? What that means is the interest is added continuously and earns further interest in further periods. We come to deltas. So what we were doing there, so if you think what I've explained to you in terms of spots and forwards were kind of in this discrete world, and then suddenly we were going into this continuous world. But as I say, there's limited use for the questions there, because most applications which we'll learn on our course are discrete applications. Therefore, the kind of formulas we learn there are key. Okay, I think that was about it in terms of the maths. Then we've got a little bit of words, which you need to probably just think about a method of how to remember things. So let's just go on to that. So, I don't know, theories of overall yield curve structures. This is easy marks if it comes up, as long as you can remember them. So if you remember, so you probably remember from your revision, there's 3 theories: expectations, what are the long-term expectations of an economy, things like that. So we're talking about debt instruments here, or bonds really, which are also a form of debt. This is the sort of the relationship between, well, if you think the economy is going to be in a problem long term, then maybe long term you'll want to invest in bonds, because they give effectively a return which is linked to the government income, rather than kind of shares which are linked to the income of corporate bodies. So things like that. So expectation. There's others. You can find some 1 or 2 other reasons on that. You don't have to go too heavy. Then liquidity. This is liquidity theory. So the shape says people will accept lower return for shorter holding times. This is so then, you know, they know they're not locked in for so long. We're all the same when we buy anything. So that would lead to that sort of shape. If you remember, the lower the yield, lower the yield means a higher price paid, so that lower return. So what that theory says is the shape would be upward sloping like that. That's a relatively classic one. Then the other thing is, it's called market, in the notes I've called it market segmentation. I think that's what it's called out in the real world. And that is about, oh dear, that is when buyers want certain durations. So, for, you know, an example here is pension schemes. You know, want secure returns in the long term. So when they're looking at their likely liabilities in 40 years, they're going to try to look for government bonds and things like that if they exist, and therefore they'll create demand there and reduce the yield. So in that case, that what that would do to this curve is that would sort of flatten it or turn it down a little bit. And I've seen that where there's been, say, some new regulations come in and said an insurance company has to invest in a certain asset at a certain duration, so it will be going up, and then suddenly you see something ridiculous like that, you know, where suddenly the demand in the market has changed, so it's dropped it down there like that. So you do see things such as that. Right. I think that's it. Oh, there's one other thing, well, two things I want to talk to you about as well. These are related to so two things. So these are related to bonds. Now the reason I put that is that we had a chapter or a part or a section, or I think it was called Unit 7 or Chapter 7 or something, Part 7 actually, which is the valuation of bonds. So we can use spot rates and forward rates, but we can use spot rates to value bonds. So in Part 7, we use the constant I usually. No, we're not. We're going to use spot rates. So so using spot rates. So that was as the earlier example, as I used earlier on in this talk. So go back to about 2 minutes, something like that. You'll see it in there. Then there's two other things I want to talk about. GRY, so the gross redemption yield. So what does this mean? Well, so we've done one. We've used the spot rate curves, so all the ITs to value the coupons and to discount the coupons and the redemption amounts, and we've come up with a price. So we've got price. We know all the income, which is the coupons and the redemption. Now, we assume we hold bond to redemption. That's where your GRY comes in, gross redemption yield. So let's form an equation. P equals, and we'll use the 3-year gilt again, if you remember. So we'll say now, got coupon, I'm going to go 1 plus G, where G is the GRY, not some growth interest rate, to the -1. And note the G's are now at on every income amount, every cash flow. -3 plus R1 plus G to the -3 again. And of course then, so what we do is we solve for G, because we've got everything else. We've got the price, we've got the coupons, I've got the formula. So we solve for G. The next thing, the final thing I want to talk about is the par yield. Now, what do we do for this one? So, what this does is it sets price to 100. And we now have the spot rates, and we have the redemption amount. So we solve for the coupon. So I'm just going to draw that up here, put a line there so you know, and then relate it there. So 100 equals, and I'll call that, I don't know what to call it, I'll call it PY. 1 plus I to the 1 to the -1 plus PY, 1 plus 2 plus PY, 1 plus I3 to the -3 plus R, 1 plus I3 to the -3. So now you can see you solve for PY, that's your par yield. So have a play around with that. Is there anything else I wanted to say? No. I think that's it. I think that's everything from this module. Make sure you do plenty of practice with the questions, which I'm going to put up today. Apart from that, good luck, I think.